So let's move on to the another question. This is a very simple question. First of all, let's read the question. So it is given that in this 5 ohm resistance, the power or the heat that is being dissipated, the energy that is being dissipated is 10 calories per second. Okay. Now we have to find the heat generated by 4 ohm resistance in calories per second. A very simple question. The basic concept here it is that current division rule is the basic concept. So if I redraw this, I can see that 4 in series with 6 and 5. Okay, so it is 10 ohms, it is 5 ohms. Okay, now if current I is going in 5 ohm resistance, then how much current will go in 10 ohm resistance? Now since both the resistances 10 ohm resistance and 5 ohm resistance are in parallel, so the voltage drop across the two should be exactly similar. So if I is going in 5 ohms, the voltage drop across 5 ohm resistance will be 5I. Same will be the voltage drop across 10 ohm resistance. So I can say that the current that is growing in 10 ohm resistance is I by 2. Okay. Now, since 4 and 6 are in series, if we go back to the same figure, so I can say that I by 2 is going here and I is going here. Okay. Now, energy dissipated per second, that is power, through a resistance is I square into R. Okay. So the heat dissipated through 5 ohm resistance is 10 calories per second is equal to I square into 5. And we have to find the heat dissipated through 4 ohm resistance, that is that is current square. What is current square here? I by 2 whole square multiplied by 4, that is I square, divided by 4 multiplied by 4, that is I square. So we have to find the value of I square, and it is given that I square multiplied by 5 is equal to 10 calories per second. So simply we can say that I square is equal to 2 calories per second. That's the answer. That's a very simple question, right? Okay. The only concept is voltage division rule, and you should know the formula of power. Okay, because energy per second or energy per unit time is power. Okay, so let's move on to the another question. Now we have to find out here, the circuit is given and we have to find out the current supplied by the battery in amperes. So this is the battery and the current supplied by it, that is I1. So we have to find I1. Okay, now let's redraw the question again, the figure. Always remember that whenever you are copying a figure, because now the gate is online, so you have to first of all copy the figure from this your screen, the computer screen, into your copy. So whenever you are copying the figure, then first of all recheck that all the figures, all the numbers which are given in the figure are correctly copied or not. That's very important, otherwise whole question will go wrong. Okay, so now this is node A, for example. We know that the current is I2 going outside, current here also it is I2, and the incoming current is I1. Okay, so KCL at node A, incoming current is I1, outgoing current is I2. So incoming current is equals to outgoing current, that is I1 is equals to 2I2. Okay, now we have to find I1. So this is node, for example B, this is node C, and this is node D. Okay, So we will apply a KVL in loop BACDA. Okay, so BACDA. Now, since the current is flowing from left to right, so the voltage drop will be left to right. Value of resistance, that is 1 multiplied by the equivalent current I1. Similarly, 1 ohm resistance also, the voltage drop will be plus at the left, minus at the right. So it is I2 multiplied by 1. Here also it is I2 multiplied by 1. Okay. So from B to A, we are entering the voltage drop from positive. So it is plus I1. From A to C, we are entering positive, so plus I2. From C to D, we are entering at positive, so plus I2. But from D to B, we are entering this 1 volt battery at the negative. So it is minus 1 is equals to 0. So I1 plus 2I2 is equal to 1. If we replace I1 by, so we have to find I1, na? So we will replace I2 by I1. So it is from this equation. I1 plus I1 is equals to 1. I1 equals to 0.5 amperes. Okay, so that's a very simple question. Now let's do another question here. So here we have to find the node voltage VA, this one. Okay. So first of all, I will copy the whole question. Now, we have to find this node voltage. Now, first of all, let us assume that this node is grounded. Okay, so let us assume that this node is grounded. Okay, and let us assume that the node voltage V at A is VA. So now we will apply simply KCL at this node. Okay, KCL at node A. So we can see that here also voltage will be VA, here also voltage will be VA. So the outgoing current, because this whole node is A node, right? So the outgoing current here, it is VA divided by 5. So outgoing current is VA divided by 5. Okay. So the outgoing current here, it is I1. The outgoing current here, it is I will remember. So outgoing current in this branch will be voltage at node A, and there is also one more voltage here, that is minus 10 I1. And since this polarity is supporting voltage VA, so it will be VA plus 10 I1 divided by 5 ohms. Okay. Okay. No. I think I have to clarify this point so that things are much more clear. So I will do it again. So this branch current, okay, so look at it here. So this is plus, this is minus 10 I1, 5 ohms. So this node voltage, and now since this is grounded and this is plus at the bottom, minus at the top, so voltage at this node, for example, this is node B. So this is minus 10 I1. Okay. Now the voltage drop across this 5 ohm resistance is, this is VA. Now the voltage drop across this is VA plus 10 I1, right? And the current will be voltage drop divided by resistance. I have to add a page here. Okay, got it? So from here we are getting this result, right? Now, and one more. So this is the outgoing current. in this branch, this is the outgoing current in this branch, this is the outgoing current in this branch, and there's one incoming current that is 5 ampere. So this is the equation, right? Now one more point. Now since this is grounded, so this will be 10 volt, right? Now if we calculate I1, so we can say that this is VA voltage, this is 10 voltage, and the resistance is 10 ohm. So it is VA minus 10 divided by 10. So this is your I1. Now put this in this equation and you will get the result. So VA divided by 5 plus I1 is VA minus 10 divided by 10. VA plus 10 I1, 10 into VA minus 10 divided by 10. Okay, so VA divided by 5, VA minus 10 divided by 10. Okay, so this will cancel. Okay. Okay, so simply I'm solving the equation. So by solving this, we can see that we will be getting, if we take 10 as common, so 2VA plus VA plus 4VA is equal to 8. So we can say that VA is equal to 80 divided by 7, that is 11.42 volts. So this is the solution of the question. So we'll be doing the next question in the next part. Thank you.